Hello, and welcome back to another episode of Kerbal Space Programming. Kevin here, and today I was looking back at some of our old code from missions past, and man, it is a bit of a mess. And I want to sort of walk you through some of the stuff that I was seeing, because I feel like there is a need for us to develop sort of a unified system for writing our libraries going forward. Here is a very dumb example that I've written up. I have this file that's just sort of a test, and then I have a library called say. We've got some say library for whatever reason. I want you to look at what's going on here. So I'm going to run say.ks, and then I'm going to say yay, and then say boo. This is a very dumb example. If I go ahead and run this, yay and boo. That's what happens when I run this program. And if we look at, if we go over into the say file, we see, okay, it's got two functions, say yay and say boo, and all it does is it prints these things out. So aside from the fact that this program is just trivial, it's actually poorly written. And there are a couple of things that I really don't like about how this is laid out. The first thing that I don't like is I don't like really that I have to be explicitly saying where this dependency comes from. That if this is my mission script, the job in my mission script should be to be like, oh, well, if the ship is in space, then do this. Otherwise, do that. Like, that is the logic that my program should be worrying about. It shouldn't be worrying about the details of where say.ks is. And generally what this, in addition, has to be, just because we're running it on the archive, it's not an issue, but if we were running this out in space, we would generally have to have something like if not exists say.ks, then see if it's on the archive volume, and then, if exists say.ks, I don't know, switch, etc., copy to 1, or what, not copy to 1, whatever the syntax is. But we'd have to worry about actually managing whether the file exists, where it exists, and making sure that it's loaded up and all of that special stuff. I don't like that. We're going to talk about that in a moment. But I also really, really, really don't like these two lines. These two lines make me see red. And I will tell you why. Part of this is just I'm getting old as a programmer. And when I look at a particular file, there are kind of three kinds of things that I see. Sometimes I'll see code like this. Local foo is 5, set foo to foo plus 5 if foo is, I don't know, if foo is 5, print something. This is code that I would, I guess, charitably call simple. This is code where if you're looking here, none of these words, these words either come from the language itself, so these keywords, generally the highlighted ones here, like local and set and if and is and to or plus, that they're part of the language. So, okay, that's part of my job to know what they mean. Or, they're just keywords that I've assigned right here. So foo is a variable that I've declared. So I'm not confused when I see foo and go, oh, what the heck is that? Well, it's something that it's just simple code that I'm writing here. The second type of code that I'm going to encounter sometimes is something like, let's see, I don't know, launch rocket, something like this. Now, so I'm going around here, I'm reading this code, I'm going here, there's no word that stands out to me as not making any sense. Now I get here and I go, oh, shoot. Well, there's a problem. I don't know what launch rocket means. I mean, I know what it means. And particularly launch rocket is a pretty well-named function. But generally, this is okay, because usually what'll happen is that somewhere, usually nearby, there's a function definition. So if I'm up here, I'm reading along, I'm trying to figure out what's going on. I encounter, oh, launch rocket, what the heck does that do? Well, I go ahead and I just type search, and then, oh, look, here's exactly what happens. And generally it's something like stage, and then stage again, and then stage. Whatever the function definition may actually be. So that's kind of the second kind of code that I'm going to encounter. The third kind, though, is very frustrating to me. And this is, to use an example from our existing code base, is something like this. RDV steer. Rendezvous steer. Now, RDV steer is a terribly named function. What I know about this is that it has something to do with rendezvous and something to do with steering, which tells me nothing at all about what is going on here. But worse than that is that this doesn't tell me where I can look. Now, generally what will happen is that I'll jump to the top of the file, and somewhere at the top of the file, there's been something like run rendezvous lib, and then some version number or something. And now, okay, well, probably it's that, because RDV probably stands for rendezvous. Or, of course, I could misinterpret RDV to mean something else. Radio, density, velocity, steer. I don't know. But it's a lot more effort for me to figure out, well, what's actually going on here. And so this really, really irks me. And that's why I get very mad when I see things like see yay and say boo, or say yay and say boo. Even though I know, okay, well, in this case, I know that they exist in that say file. One other thing that is a big issue with this is that now it means that by using the say file, there are consequences. Bad consequences. That even if I don't run, even if that's the only line of the program, there are some consequences. Specifically, that now if I were to try and use that as a variable name, well, the system is going to crash. Running the say library now means that say has called dibs on a bunch of words that I can't use anywhere else in my program. And with say yay, that's probably fine, and we've prefixed these and they're generally okay. But sometimes if you're running a bunch of different libraries, now you've got to make sure that none of them call dibs on the same words, or you're going to end up with problems. So what did we do? Some of the stuff, so I'm going to go ahead and jump into this say library. What we did to try and fix this is we adjusted our libraries to go like this. So we put them first in braces so that these functions wouldn't be public, so they're not going to pollute globally. Now, of course, if I try and run this now, oops, let me copy that, and then run the program, now the functions aren't available to be run because they're private. So we have to get them back out again. So what we would do is would say global say is a lexicon, and would say yay is the say yay delegate, and boo is the say boo delegate. And that'd be what this would be what our library does. So now instead, these functions are private, but it's still going to take this one reserved word and say, all right, I'm just going to hide everything in there. And then if we go back, instead of doing say yay, I'd say, and then I'd just get it out of that lexicon, and then say boo the same way. And if we run, yeah, let me make sure I've copied everything over. And there we go. Now it works the way that it works before. I'm still a little frustrated with this, though, because it does mean that say word I can't use. It's a lexicon, and it has to exist as a lexicon. And if I assign it to something else, that's going to break things for other parts of the program. Is there any way that we can have the program not even decide what its name? The libraries shouldn't be in charge of what keyword it adopts. What I would like to do is say something like local, my cool name is something, for say.ks. And so then say doesn't exist. Only my cool name does, and only because I wrote it in my particular program. And if someone else wanted to import say, they could name it whatever they wanted to. And then they could make sure that they don't have naming collisions only within their own file, and they're not going to have to worry about collisions with other libraries. Now, a couple of things that we would need to have this happen. In fact, I don't want to call it something. What are we actually doing? Well, we're importing the result of some file, right? What we're trying to say is, give me whatever this library is. I want to import it. I want to use it. And then I want to assign it to a variable name. Just like when I say, local foo is 5, I want to be able to say local, my lib is import foo lib or whatever. So that's what I want to be able to do. Now, of course, import say.ks like this is not going to work. So we're going to have to put some strings around that. But that brings up a bit of an issue because the run command doesn't let you do things like that. If we try and run that, and actually if we just try and run that, it's going to get very angry because it doesn't know how to run strings. Okay, maybe it does now. I don't know. Okay, I actually didn't test. I should have probably tested that. That's a bit weird. Maybe it does run now. But anyway, there's a cooler thing that we get with KOS 1.0, and that is run path. And this does absolutely accept strings. And wow, okay, yeah, there's a lot of reasons this should have failed. I'm not sure why this didn't fail. Run path does accept strings. Not only does it accept strings, it accepts folders. So we could say my folder /say.ks. Now that's something that's pretty cool because it means that we could eventually say, you know, let's imagine that we have some sort of directory structure, and I'm just going to try and, I guess, fake it out here. We have, I don't know, ship script, and inside ship script, we have another folder that's, you know, the cool mission, and inside that cool mission folder, we have, you know, mission.ks and, you know, foolib.ks. And then inside some other folder, we'd have, you know, library, and would have a more general foolib.ks. So basically, if you imagine that this is the folder structure, we could actually say that, okay, import's job is to worry about not just running the file, but also figuring out where the file lives. So seeing, oh, is it on the ship? Well, great, then we'll just run that. Is it not? Is it in the folder for our mission? Great, well then we'll use that. Oh, it's not. Is it in our general library folder? Cool, well we'll use that. Now it's no longer this current file's problem to worry about exactly where all of these dependencies are. All I'm going to say is, you know, local maneuver, is import maneuver, and then just know that it's going to go ahead and resolve that based on a couple of rules, and not have to. And I don't then have to specify, oh, copy these over and make sure they're in the right place, because that's not really what my job is as the mission program. Really, there are two kinds of code that we've been doing, that we've been writing. There's the first bit is what to do, and the second is how to do it. Right? So these are our mission scripts. Whoops. And these would be libraries. So the mission script should be much more high level. It's just saying, hey, let's go to space, let's go to the moon, let's orbit, let's deorbit, let's do whatever. The libraries are saying, okay, here are the details of exactly how those get executed. So the problem is that we've had an awful lot of kind of detail-oriented stuff that has to live in our mission scripts because of the way that things are organized, and I want to get away from that. So since we have run path, this means we can do some stuff. If we ignore that sort of brief divergence, yeah, okay. So let's use an example here. So let's try and actually import local say is import say.ks. And I hope this doesn't work, because if it does, then something's weird. Yeah, okay, there we go. Undefined variable named import. Right, well, that's as we expected, because we will need to write it. So I'm going to go ahead and write a function here. Actually, I'm going to go ahead and just, I'm going to do this in line. I guess we got to put it at the top, right? Yeah. I'm going to do this in line. We'll eventually move this into its own file, because this is kind of the start of a framework that we can use to manage our own libraries. I'm going to go say global import is a function, and it's going to have to take a parameter name, because we're passing in a name, right? And what it's going to do, well, it's just going to run path name. So really, this is the same as just running say.ks for right now. If I go ahead and run this, I think I missed a period somewhere. There we go. And now it's upset, which it makes sense because we're assigning say to something, we're assigning it to the return value of import, and import does not have a return value. Import needs to return something, and we don't quite know what to return. So what would it look like in our library file? Well, right now it's returning the global, it's just putting the thing that say wants to export is here, this lexicon. But right now it's just assigning it to a global say, and we're then overwriting it here. And this is that naming collision that we were talking about. What if instead the program could somehow just, that our library program could just say, here's what it is. I'm not going to tell you what to name it. I'm not going to pick any magic words that I'm going to call dibs on. Here's what I want to export. Well, let's do that. Let's say export. There. Well, we'll need a, there. That's what I want this to do, right? I mean, I don't care that I'm say.ks. I don't care what you're assigning me to. I don't care anything. I'm just saying, here's all the stuff that I can do. You tell me what you want to do with it. I'm going to go ahead and save that and copy it over. Of course, it's not going to run. We'll go ahead and close that. Now we need to go back to our sort of test file. If I go ahead and run this, then we're going to get some errors. Undefined variable name export. And this takes a value because we exported that lexicon to it. But we're still going to, if we run this, we're still going to end up with the same issues before that. Yeah, it can't iterate on an object. There's no say yay because there's still no return value for this import. This import has to somehow return whatever was exported. So what I'm going to do is I'm going to create a local, let's see, a local current file is 0. And right here, whenever we call import, I'm going to say set current file, to name. Then I'm going to run path. So what's happening here is I go ahead and I say import say.ks. We go, okay, well, I'm going to set the current file to say.ks, and then I'm going to run say.ks. And now, because I've set current file to that, export can access current file and use that to say, well, here's what we'll go ahead and save something away. So we'll go ahead and say set, we need some sort of, not an archive, but like a diction, let's see, we'll call it lookup. We'll say lookup for current file is that value. Of course, that means that we actually have to have some sort of lookup, which will be a lexicon, just a set of keys and values. And then once we're done running the file, well, now it should be in our lookup table. So I can go ahead and return lookup name. So what we're doing now is this is a little bit confusing. So import takes the name, it sets it aside. So it says, this is the thing that's currently running. Then it runs the file. Now the file runs and it calls export. And export knows, hey, the file that we just started running is called say.ks. So when you call export, I'm going to go, oh, perfect. I was waiting for you to tell me something, and now I know where to store it. And then once that file is done running, now we go, okay, great. Now we've gone ahead and run it. It's exported, and we're going to get that value back out. So now theoretically, our lookup lex should be something like, say.ks is, that lex of whatever the heck was there. Okay, so let's go ahead and run this now. Nope. Oh, yep, because I used is instead of to. Set lookup is value. That's weird. Okay, not sure how I made that mistake. There we go. Yay and boo. Now, this is very small, but look what we've done. I can now change this to be foo. And everything will still run entirely just fine. I don't have to worry about naming collisions. Now, there's nothing at all. Everything, the entirety of this library is private. The only thing that's coming out of it is being exported, and even that's not being made public. It's only accessed because it's a return value. There's nothing in this file that can break other libraries because none of it can get out. It's within these braces. So this is a very small thing, but we're going to go ahead and build on this because what it means, in addition to the fact that we've avoided these key name issues, we also now have this import function. Now, I'm going to go ahead and probably work on this over the next week, have import, check those various rules for, let's see if it's on the current on the current ship. If not, let's go ahead and see if it's on the archive and copy it over and worry about all that, so that no longer will our mission scripts have to worry about doing all of that obnoxious setup. We can just say, here are the things that I require. Here are the things that I'm dependent on. You figure it out. And of course, I'm going to go ahead and you've always got to give something a name. So I'm going to call this KNU, which is a play on GNU, which stands for GNU's Not Unix, which is a good, fun Linuxy term that I don't think we'll get into. I suppose we could call it KNU for GNU's not Unix either, but I think I want to keep it short. Basically, what I am doing, I'll go ahead and say global KNU is Alex, just for right now, which has a version number of 0.0.1. All right, there we go. Version number of 0.0.1. What I'm doing is I'm calling dibs on these three words, KNU and import and export. And this is going to be the way that we start to build up our framework. We can start to write libraries that are isolated, that we can easily import and refer to. We'll probably eventually build in a versioning system so that we can specify precisely which versions we need for individual missions. And I'm looking forward to building this up over the next while. But depending on when KOS comes out, we will probably be launching missions very soon. I'm going to go ahead and try and rewrite some of our libraries in this new format. But I thank you for watching. Let me know what you were itching for, what you're thinking of the series thus far. Because, yeah, I mean, I know we've been doing a lot of kind of code-heavy stuff over the while. I think I finally got a Windows machine that is not dying some of the time. So as soon as KOS 1.0 is out, we will be on that. Other than that, I will see you all next week. Cheers.